Hi students, today we are discussing about ultrasonic sensor interfacing with Arduino Uno R3 processor. So here we are looking ultrasonic sensor. This is our ultrasonic sensor. It is interfaced to Arduino board, and here I wrote a program when an object comes within the distance of 5 centimeters. So the object is identified very nearer to the sensor. So LED will glow. On the other case, LED will be off. So here Arduino is on because it is connected to my laptop. So power supply is connected to Arduino board. And when you see the Arduino sensor, you can see here we have ground pin, second pin echo, and third pin trigger, and fourth pin is VCC. Okay, and here we need to trigger the sensor in order to produce the sound waves, and we know that the sound wave speed is 340 meters per second, and we can also tell it in centimeters like 0.034 centimeters per microsecond. So the time need to travel in centimeters, we can also measure in that way, isn't it? So here we need to enable the trigger for at least 10 microseconds in order to uh, detect the sound wave. And here the trigger will enable the sensor to produce the sound waves. And then the echo will receive the sound wave reflected back to the sensor. So here the echo distance will be twice because the colliding distance and reflecting distance, isn't it? So we have to write like the distance by 2, isn't it? So that is 0.034 centimeters per microsecond whole by 2, isn't it? And now we'll see the programming concept. Let's have a look at the programming concept. So here the echo pin is connected to 8 and trigger pin is connected to 9th pin of Arduino, and LED we are using for indication is connected to 10th pin, and the duration and saving and the duration variable and distance is calculated with variable distance, and the trigger pin is set as output mode, echo pin is set as input mode to receive the reflected pin, and baud rate is 9600. And here initially we're setting the trigger pin is low and delay microsecond. So here 2 microseconds delay is applied to before we are setting the trigger pin, and after the trigger pin is set for high, and here microsecond 10 microsecond delay is produced with the function delay microsecond, and after that the trigger pin is made high for 10 microsecond, and after that the trigger pin made low. Then we have uh, reading the pulses received on echo pin. So pulse in is the function to read the signals in pulses. And next, as we have discussed earlier, the distance is calculated by the duration time into 0.035 by 2. We have already uh, discussed about this too, isn't it? Because the wave is traveling in both the directions, and then we are displaying the distance in centimeters. And here, where we are uh, switching the LED on and off when the distance is less than or equal to 5 centimeters, then we are writing a high signal on the LED. Otherwise, in the remaining cases, that is when the object is far away, then the LED will be off. Okay, let us see the hardware. So you can check the sensor values. When the sensor is moving, see here, when the distance is less than 5, the LED is on now. When it is near to 5 and after 5, it is off. And just when it is between 5 and 6, it is fluctuating, isn't it? In between 5 and 6. It is 6 and more. When it is nearer to 5 centimeters, LED is on. And 5, 4, 3, 2, and 1, isn't it? So when it is moving away 5 centimeters, LED is off. And when it is nearer to 5 and in between 5 and 6, the LED is fluctuating. You can clearly see the difference. The LED is fluctuating, isn't it? That is when it is 5 and 6, isn't it? So in this way, we can control the LED based on echo signal.